All right, here we are, folks. Last video in my three-part series of the basic rules of integration and antiderivatives. So you'll find in these examples, these are a bit different. It's not just simply basic rules here. I'm dealing with position, velocity, and acceleration. So recall that you differentiate each time. So now we're going to go backwards and we're going to integrate from acceleration to velocity to position. So in this case, I have the acceleration of a particle at time t. And I have some initial conditions here. So that'll help us find those values for each of my velocity and position equations. All right, so first I'm going to find my velocity equation by taking the antiderivative of acceleration. So I'm going to do that. I'm going to use my power rule for antiderivatives, and I'm going to end up with 2t squared minus 3t plus c. And I'm going to be using other c's later on because I got to do it again here. I'm going to use c1. So I like to use a little subscript just to make sure that, like here when I do s of t, right? S of t, I'm going to end up with 2t cubed over 3. So t, because I'm taking the antiderivative of velocity, minus 3t squared over 2. Now when I take this one, notice here, I could end up with a C1 here if I didn't have my initial condition. So that's why, and then I'm going to do it again. I'm going to end up with, I'm going to end up with a C at the end because every time I take an integral where I don't have a condition, and I don't know what that C is, I have to take that C at the end. So I'm going to end up with a C2 here. So I'm going to use C1 to begin with. Now I know my initial condition here, so I'm going to plug in that to solve for C. So V1, V sub 1, is 2 times 1 squared minus 3 times 1 plus c sub 1, and I know that's going to be equal to 6, right? Because that's the information I'm given. So I'm going to solve that out for c1, and I'm going to get c1 is equal to 7. So my equation of my velocity, v sub t, is going to be equal to 2t squared minus 3t plus 7. All right, so then I'm going to go and finish this guy off. I know it's 7 here, so I'm going to have plus 7t, not 7d, 7t, plus my constant, c2, plus c2. And I'm going to do the same thing I did last time here. I'm going to put s sub 2 in, because that's my initial condition for my position. All right, I'm going to get 2/3 to the third power minus 3/2. 2 squared plus 7 times 2 plus c2, c sub 2, and that's equal to 5. I'm going to do all the math there, bada bing, bada boom, do some math, then I'm going to get negative 25 over 3. Over 3. All right, and then I am going to put my equation, my formula for s of t. So s of t is 2/3 t cubed minus 3/2 t squared plus 7t minus 25/3, and I got that from here. All right, so now I got v sub t and s of t. And there you go. That's how we use integration for position, velocity, and acceleration problems. We're going backwards now, guys, backwards. All right, so let's take a look at this one. We're given that on Earth, the acceleration of object due to gravity is approximately negative 32 feet per second squared. So we're going to come up with the equation of velocity. So we're going to take the antiderivative of negative 32, and we're going to get negative 32t plus c1, c1. I have an initial velocity. My initial velocity of v sub 0. It's when my time is 0. What is my c? Well, that's going to be, we're just going to call it v sub 0 for initial velocity. So our velocity expression, v sub t, is going to be negative 32t plus v sub 0. Some physicists you'll hear them call that v naught. Okay, now we're going to take the antiderivative here. We're going to get negative 32t squared divided by 2, which is going to give me negative 16t squared plus v sub 0 times t, because I'm taking the antiderivative of this, plus c sub 2. And we know S sub 0 is equal to, all this is 0, which is just going to give me C sub 2. And we're going to call that S sub 0 for initial position, or S naught. Don't say that very, very fast a few times. I stayed silent so you can try it to say that. Try saying S naught very, very fast. Plus S sub 0, and there we go. You'll need a tissue after you say S naught so many times. Okay, just a quick note here. V sub t, these formulas that we came up with at the end can be used for any motion affected on Earth's, only by Earth's gravity, okay? All right, guys, that's position, velocity, acceleration using anti-differentiation. See you guys later. Bye-bye.